this lesson, we are going to talk about relationships between lines. And so we are going to look at two lines and talk about if they are parallel, if they're perpendicular. We're also going to talk about coinciding lines. And from that, determine if they're going to have one solution, no solution, or many solutions. And then once we've got that down, we are going to look at how to write the equation of a line when you're given that relationship. So if we know two lines are parallel, what is the equation of this new line? Or if we know two lines are perpendicular, what is the equation of the second line? So I have this section for you here on your handout with all the different definitions you might need. So it has here what a reciprocal is in case you've forgotten, because that's going to be very important in this lesson. And then I have the different types of lines. We have parallel lines, coincident or coinciding lines, and then perpendicular lines. And this is a really great cheat sheet for you to look at. What I do want you to notice is that, let me switch here to a highlighter for you, all of these focus on slope first. So that's really, really, really going to be important to pay attention to as we go through these lessons. Okay, we're going to focus on our slopes of these lines, and that will help us figure out whether they're parallel, coinciding, or perpendicular. And if they're not any of those three, then we know they're just intersecting but not perpendicular. Okay, so let's get started. So let's start with this first one. The first thing that I actually want you to do is I want you to graph, okay? Normally you won't have to graph, but for the sake of the note so we can see what these actually look like, I want us to graph these equations on the same, so both lines on the same picture. So I'm going to start with this one in red. And so which one of those is my y-intercept? It's the 2. Do you remember y equals mx plus b? And we always start with b, which is our y-intercept. Now, if this is a y-intercept, am I going to go up 2 or am I going to go right 2? Remember, this is on the y-axis, and so that means I want to go up 2 spaces from our origin, and that's where we start. And then from there we have our slope, and remember that slope means rise over run. So I'm going to be going up 1 and right 2. We always run to the right when we're starting out. So I'm going to go up 1 and over 2. That means your next dot should be there. Up 1 over 2, up 1 over 2, up 1 over 2, and up 1 over 2. And then we can draw our line. There we go. So again, this red line is my first equation. I can take all this other stuff off for you. But it's my first equation is in the red line, just to help you remember it. Okay, so now let's go look at our second equation. And our second equation I'm going to do in blue. And so which is my y-intercept? So thinking back again, remember y equals mx plus b. That negative 3 would be our y-intercept. So where am I going to go with that negative 3? I'm going to go down 3. So 1, 2, 3. There's my first dot right there. And then my slope. My slope here is negative 2. So I'm going down 2 and over 1. Down 2 and over 1. I'm also going to go backwards in this case because I ran out of space going forward. So I'm going to go backwards, which means I'm going to go up instead of down, and I'm going to go left instead of right. So both of those become opposites. Remember, this slope is negative, and so that means that my line should be going down from left to right. It should be decreasing from left to right because it is negative. Okay, so I've got these two lines here, my red line and my blue line, and I want you to really look at these. In how many places do these lines cross? Just once, right? They cross right here. Now these type of lines are very, very special. We call these perpendicular. Okay, these are perpendicular lines because of the way that they cross. They cross in a way that every single one of these angles we call a right angle. They are 90 degrees. Okay? Now, they cross one time. That means if you're ever asked for a solution, they have one solution, but they are perpendicular lines. Remember that. Depends on what the question is asking you. If the question is asking you how many solutions, they would have one. If the question is asking you, are they parallel, perpendicular, coincident, or just intersecting, we would say they are perpendicular. Now let's go look at the equation. Remember I said that all of these will focus on the slopes. Take a look at your slope. What do you notice? Well, one thing I notice is that one is positive and one is negative. We have that positive 1/2, and we also have the negative 2. The other thing that I notice is I have this fraction 1/2. What happens if you flip that 1/2 over? Well, we would get 2/1, right? So do you notice how these slopes are reciprocals? Look back at the top of your vocabulary section on your handout, and you'll see that reciprocals are flipped fractions. Do you agree that 1/2 and 2/1 would be flipped fractions? Yeah. So these are reciprocals. So what we say to shorten this definition is that when you have perpendicular lines, make sure you've made a note that these are perpendicular, okay? But when you have perpendicular lines, we call them opposite reciprocals. Opposite meaning they have opposite signs, one positive, one negative, and reciprocals meaning they're flipped fractions. And here's the important thing, you have to have both. You can't just have reciprocals, 1/2 and positive 2. You can't just have a positive 2 and a negative 2. It has to have both, the opposite and the reciprocal part, in order to be a perpendicular line. So let's go look at another example. If we look at example 2, let's start by graphing these. So here I have graphed them. I have the first line graphed in red, and I have the second line graphed in blue. I started my red line at positive 2 because of that y-intercept, and then I went up 3 and over 1, up 3 and over 1. If you need to go back and review graphing, that's going to be in Unit 3. So you can always go back and check your notes from Unit 3 on how to graph a linear function. Now, let's talk about what these two lines mean. Okay, so these lines, look at them. How many times are they going to cross? They don't cross, right? And they never will. That's kind of the important thing. Every time this line, this blue line goes up 3 and over 1, this line is also going up 3 and over 1. They're never going to cross, okay? Now, what that means is if you are asked for the number of solutions, a solution is where the two lines cross. If these are never going to cross, are you ever going to have a solution? No. So we say that these two lines have no solution, okay? Now, is that what this question is asking? No. This question is asking, are the lines parallel, perpendicular, coincident, or just intersecting but not perpendicular? Well, these two lines are parallel. Now, this is super important. Parallel and coincident lines get confused all the time. Coincident lines also have a similar way of remembering them. So if you look at your equation, what do you notice about the equations? Do you notice how the slopes are the same? I have a slope of 3 in the first line and a slope of 3 in the second line. Well, that's kind of what makes these parallel. They have the same slope, but check out your y-intercepts. Your y-intercepts are different. That's what makes them parallel. Coincident lines are like the same line. Okay, if I had the same slope and the same y-intercept, that would be coincident lines. That would be one line on top of the other. But this is not. These have two different y-intercepts. Okay, now because they are two different y-intercepts, that makes them two separate lines that are just never going to touch. So you have to be very careful. To be parallel lines, you want to have the same slope, but you have to have those different y-intercepts. If you have the same y-intercept, check out what happens. So let's say we have y equals 3x plus 2. We have y equals 3x plus 2, okay? Now, right away, you can already tell these are the exact same line, right? I have the same slope, and I have the same y-intercept. So let's start, I'm going to graph in purple with my first one. So my first one, I'm going to start up 2. And then I'm going to go up 3 over 1, up 3 over 1. I can also go backwards. Okay? And then I can draw my line. And then I can do my second line. So I'm also going to start at a positive 2. And then I'm going to go up 3 over 1, up 3 over 1. What are you noticing here? I'm going to be plotting my line right on top of the other one. That's the difference that y-intercept makes. Okay? You can't even see my blue line anymore because I graphed the green line right on top of it. They create the same line. These are coincident lines, or sometimes we say coinciding. Okay? When they have the same slope and the same y-intercept, that makes them coincident. And I believe I have that on your vocabulary part. They are the same line. They have the same slope and the same y-intercept, versus parallel lines have different y-intercepts. So don't get those confused. All right, so then we have example 3. Again, we're trying to see are the lines parallel, perpendicular, coincident, or intersecting but not perpendicular. So let's look, and first I want you to look at the slopes. We have been talking about how important those slopes are. So what is the slope of the first line? 2. And what is the slope of the second line? -2. Now let's think back. Are these slopes the same? No, +2 is very different from -2. So they are not the same. So can these lines be parallel? No, because to be parallel, they have to be the same. What is the other relationship we know is gone? Coincident. That's the other one where you have to have the same slope. And these are not the same. They're similar, but they're not the same. So let's think about perpendicular. Perpendicular is the other special one that we've talked about. Now, to be perpendicular, you have to have one positive and one negative, which we do. We have a +2 and we have a -2. But what is the other piece to be a perpendicular line? They have to be reciprocals. So if I have a +2, what is the reciprocal of 2? 1/2. Is this slope 1/2? Nope. So it can't be perpendicular. That means that these lines are just intersecting. Okay? Now let's look at what that looks like. All right? So if I have here, take all this stuff off, we already know that they're just intersecting because we compared those slopes, right? So let's take a look at what they look like so that you understand this. I'm going to start with this first line. So I'm going to go up 2 because that's my y-intercept, right? And then my slope is up 2 over 1. All right, so I've got my red line graphed. Now let's go do my other line. Let's do it in blue. Okay, so I'm going to start at -5. 1, 2, 3, 4, 5. And my slope now is a -2. So I'm going to go down to, I ran out of space, so I'm going to go backwards. Okay, so I've got my red line and my blue line. So notice how many times do they intersect? They only cross one time. They cross right here. Okay, so that means that they would have one solution if you're asked that question. Again, this question was asking us what's the relationship. These lines are intersecting but not perpendicular. And here's why they're not perpendicular. Take a look at this. See how between these two lines we have a smaller opening, and then between these right here you have a larger opening. So these openings are not all the same size. These two on the sides would be the same, and these two on the up and down would be the same. We call those vertical angles. Not important at this moment, but what is important is that they're different sizes, versus if we look back at our first example, all of these openings are going to be the exact same size. Okay, they're all 90 degrees. In this example, they are not all 90 degrees. And that's what makes them kind of not special, in that they're just intersecting. They're not perpendicular. Okay? Now you can shorten this to I, B, and P if you want. As long as you understand, that means that they are intersecting, but not perpendicular. Okay? So those are all the different types of lines. Let's take a second and just look at those, ingrain it in your brain, maybe try a couple practice questions before we move on to the next piece. So now that we've reviewed the different types of lines, let's talk about writing the equation of a line, knowing that relationship. Okay, you're going to need to go back and look, I think we did it in Unit 3, at the point slope formula. Okay, writing the equation of the line. Y minus y1 equals m times x minus x1. If you don't remember that, go back and review it. We did it back in Unit 3. I promise it's there. So this is asking you to write the equation of the line. Boom, that's when I know I need this formula. That is parallel to this equation. Okay? And then, of course, we've got this point. I'm going to go ahead and label my point x1 and y1 because that's where it's going to get plugged in my formula. Okay? What is the other piece of information we need in order to plug into that formula? We need m. What does m stand for? It stands for the slope. Now, if we know the relationship to this slope right here, can we write the equation of the line? Yeah. If we're looking for parallel lines, do I want a same slope or a different slope? For parallel lines, we want the same slope. I mean, go back to your vocabulary and questions piece. Parallel lines, same slope. So then what is the slope that we are looking for in example 4? It's 2/3. We're going to take the slope out of this equation and leave it the same. So our m is going to be 2/3. So we just plug that into our formula. I've got y minus my y1, which was 2. That's going to equal my m, which we know was 2/3, times x minus my x1, which was -6. Do a little housekeeping here. I see a negative, negative. Remember, if we do a stay, change, change, that means the x is going to stay, but both of these are going to change. Okay? After that, we're going to do our distribution. So I'm going to take 2/3 times x. Just makes 2/3 x. Is any of this coming back to you? I hope so. I can use my calculator to help me with 2/3 times 6, or I can just think about 2 times 6 is 12 and divide that by 3, which I know is 4. And this is going to be a positive 4 because these are positives here. Then I'm just going to bring down my y minus 2 equals. Now remember, our goal is to get to y equals mx plus b. So what is the very last step I have to do here? I've got to add 2 back over so that I can get y all by itself. I'm going to bring down my 2/3 x, and I'm going to bring down the plus 6. There is my equation of a line that is parallel to this equation up here. However, it goes through this point. Okay? So let's look at example 5. Same thing. It's saying write the equation of the line. So I'm going to need that point slope formula. Same formula I just used in that example. This time, though, the relationship we're talking about is perpendicular. Okay? So let's go pull that slope out of the equation again. So we're looking at 2/3. What do I need in order to make that slope a perpendicular slope? Think back. Go look at your vocabulary questions here. We need an opposite reciprocal. So opposite meaning they need different signs. So if this slope is positive, it means my new slope needs to be negative. Then what does reciprocal mean? It means we've got to flip that fraction. So instead of 2/3, I want 3/2. That's my new slope. And then I've got this point x1 and y1. So again, we're plugging stuff in here. Okay? So I'm going to start with my y minus, and my y1 was 2. Then I've got equals, oops, my m, which we found to be a negative, that's the opposite, and the 3 over 2, that's the reciprocal. Then I have x minus, and I have a negative 6. So same point as last time, but this time we're finding the perpendicular line, right? So again, we've got that housekeeping. We do the little state change, so these become a positive. I'm going to distribute. Now be careful here because your slope is negative. So I've got a negative 3 over 2x. And then what's a negative times a positive? It's a negative. So this time I'm going to take the 3 times 6, which is 18 over 2, which is going to give me 9. Again, you can also use your calculator to help you with that part. Then I have the y minus 2 equals. I'm going to add 2 to both sides. And we get y equals a negative 3 over 2x minus 7. That would be my equation of the line. I know I'm done because y is all by itself, and it looks like y equals mx plus b. Cool, I think it's time to go try some questions.